5.3, proving that a quadrilateral is a parallelogram. So what I'm going to do is I'm going to try to center this just for you, because we have 2 examples and a few things that students are going to need to write. So let me center this right about there. I recommend that the substitute teacher press the enter button to pause the video, and then press in the enter button again to replay the video, and I would do that now. Coming back to you. So this is what you wrote down. I'm going to read it to you, and what I like about 5.3 is that it's just the converse of what we learned in 5.2. In 5.2, we learned that if something was a parallelogram, if a 4-sided shape was a parallelogram, then there were certain properties that had to be true. But in 5.3, we're going to learn that the converse of that is true. The converse is where you switch the hypothesis and the conclusion. Where in 5.2, we said if it was a parallelogram, then this property was true. We're going to do the opposite. We're going to say if the diagonals bisect each other, then it must be a parallelogram. If the opposite sides are congruent, then it will be a parallelogram. Let's look at what theorems 45 through 49 say. If a quadrilateral has both pairs of opposite sides are congruent. Draw. Okay. If I know that both pairs of opposite sides are congruent, then it must be a parallelogram. It's just the converse of what we did before. Here's the picture that goes along with what you just wrote down. Let's do statement number 2. If one angle is supplementary to both consecutive angles, so the minimum that you need, let me draw you another little parallelogram here. The minimum that you need is you need one angle, let's say angle 2, is supplementary to both consecutive other angles, 1 and 1. And angle 1 plus angle 2 must equal a sum of 180 degrees. If this angle is supplementary with this consecutive angle and this angle, that's the minimum that you would need, then you know that it must be a parallelogram. What this means, if these are supplementary, is that these 2 lines are parallel. And if these 2 are supplementary, it means that these 2 lines are parallel. And so that would mean that the opposite sides are parallel, therefore it has to be a parallelogram. It's kind of it should make sense to you. That's the minimum. If both pairs of opposite angles are congruent, let's say you didn't know what their sum was, but you knew that this angle was the same as that angle, and this angle was the same as that angle. If I know these pairs are congruent to each other and these pairs are congruent to each other, then it must be a parallelogram, even if you don't know what their measurements are. If the diagonals bisect each other, if this diagonal from this corner to this corner cuts this diagonal into 2 congruent pieces. This one goes through the midpoint, and this one goes through the midpoint, then these 2 pieces will be congruent to each other, and these 2 pieces will be congruent to each other. Therefore, it would be a parallelogram. The last one is the trickiest one. It would be the most complicated to prove if you were trying to prove it. It's one pair of opposite sides are congruent and parallel. This one I want to draw a quick picture for you, of course, just like we just did. One pair of opposite sides are congruent. If I know that this is congruent and this is congruent, and they're parallel, they have to be parallel as well, then it's also a parallelogram. Now, this, if I move the congruent ones to here and here, it would not necessarily be a parallelogram. They have to be on the same sides that are congruent and the same sides that are parallel. because we do not want to have the possibility of creating a trapezoid which has one parallel sides, and it could be isosceles and so on like this. Let me show you what I mean. This is parallel to this, and this is congruent to this. This is not a parallelogram. This is a trapezoid. This is not going to work. So make sure that these are on the same side. The parallel sides and the congruent ones are the same ones. That will make it a parallelogram. So these are your 5 conditions. If I know these 5 conditions, then I can prove that it is a parallelogram. They don't have any names, these theorems. The theorems are numbers 45 through 49. These are not like fancy Pythagorean theorem names. They are numbered from this textbook. So it's not like you have to know their names. You just have to know that these properties prove that something is a parallelogram. If you understand that, you should be able to do all the properties or all the problems that I have assigned in your homework. But just to get you started, I have 2 problems, 2 examples for you that we're going to do together. Number 4 in your book. If you would like to get your book out and open, feel free to do so. We can do this together. It states, can you prove that the quadrilateral is a parallelogram based on the given information? Explain. So I look at this and I say, ooh, it looks like a parallelogram, but the only information given is that this is congruent to this. Ooh, okay. This diagonal bisects this diagonal. I'm going to go back up to what we wrote. Let's see. The diagonals bisect each other. Do you notice that this is plural? Diagonal, bisect each other. That means that both have to bisect each other. We only know that this one bisects. This could be 2. This could be 3. That'd be a funky shape. It might look like, if you think about it, like you're playing around with shapes in your mind, that would make the shape look something like this. And then that'll be a little bit longer. But remember, these are the only 2 things that we know are congruent. So imagine that this is really, really, really close to being that, but it's not exactly. So my answer to this is no. The diagonals, both diagonals need to bisect each other. Kind of like one of those little tricky things that we need to make sure we're paying attention to. When you write down notes, make sure that if there's an S there, that there's plural. It's plural. You need both. Let's jump to number 17. Now, there's a variety of questions like this. For what values of the variables must A, B, C, D be a parallelogram? Meaning, what do these variables have to be so that this would be a parallelogram? Okay, well, if it's going to be a parallelogram, the opposite angles need to be congruent. Okay, well, that needs to be the same as that, and that needs to be the same as that. But if I do B and D, that's 8x plus 5, and that's a 5y. That'll give me an equation with 2 different variables. So I'm probably not going to go this route. But if I do this angle here, angle A, and angle B, I know that if it's supposed to be a parallelogram, that these 2 angles should add up to 180 degrees. They need to be same side interior angles or consecutive interior angles. So I'm going to write an equation. 3x plus 10 plus the 8x plus 5 should sum to equal 180 degrees. What does that look like? 3x plus 8x is 11x. 10 plus 5 is 15. It's equal to 180. Subtract 15 from both sides. Pretty sure that's 165. Pulling out my calculator because, don't want to mess up the video. Divide by 11, divide by 11. X is equal to, divided by 11, 15. For what values of the variables? Yay, we have 1. We have x. X has to be 15. So what I'm going to do next is, since I want to know what this angle is, I can plug this into either angle. I'm going to plug this in right here. 8 times 15 plus 5. I want to know how big angle B is. 8 times 15 plus 5. I'm using my calculator. Means that angle B has to be 125 degrees. I could have easily plugged that in over here, but now that I have angle B, now I know what this has to be equal to. Opposite angles in a parallelogram have to be equal to each other. 5y has to be the same as 125. That's how I'm going to figure out what y is. I'm going to divide by 5, and I'm going to get what y is equal to. 125 divided by 5, y has to be 25 degrees. And I have figured out everything about 17. Hopefully that gets you started. We'll see you in the next video.